Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from power system stability, and the name of the topic is nothing but swing equation. Now, what is basically a definition of a swing equation? The swing equation is the differential equation that relates the angular momentum, which is denoted by capital M, then accelerating power PA, and rotor angle or load angle delta. So how one can define a swing equation? It is the equation, or you can say differential equation, that relates the angular momentum M, accelerating power PA, and rotor angle delta. The swing equation will show how the rotor angle changes with respect to time when it undergoes a disturbance. Whatever the plot that we always used to graph, or whatever graph we always used to plot in between load angle delta, which is there on y-axis, and time t on the x-axis, we will get swing curve. The stability of the system can be assessed with the help of swing equation. So for a synchronous generator, we know that what is the input? Input is the mechanical power, that is Pm, and output will be nothing but electrical power, that is Pe. Now in case of synchronous generator, the speed is denoted by omega s. So this is what is the speed which is denoted. And the torque, there are two torque. First one is a mechanical torque Tm. This is shown here, which will be in the same direction as that of your omega s. And your electrical torque is nothing but Te, which will be in a counter direction or opposite direction. Here it is shown in a figure A of synchronous generator. Now when we talked about the synchronous motor, then we know that input is nothing but electrical power and output is nothing but a mechanical power. Now what happens in a synchronous motor? Whenever the speed is omega s, the electrical torque Te is in the same direction. So this omega s, here we have shown it like this. So Te will be in the same direction. On the other hand, the mechanical torque will be in opposite direction. So let us see the swing equation, the swing equation governs the motion of the rotor, relating the inertia torque to the resultant of mechanical and electrical torques on the rotor. Now let us assume that if the windage, friction, and the iron losses of the machine are assumed to be negligible, then how we can write the torque differential equation? How we can write a differential equation? It is very easy. Accelerating torque Ta is equal to moment of, I write it here, okay, just a minute, I will write it here, moment of inertia into your angular acceleration. Into what? Angular acceleration. This is the basic formula. So therefore we can write moment of inertia into angular acceleration. So J d square theta m upon dt square, which is equal to Ta. This Ta is nothing but what? Difference between mechanical torque and electrical torque. So mark this as a equation number 1, as it is the equation of the torque. So therefore we have a unit in Newton meter. What is J here? J is the rotor moment of inertia in kilogram meter square. Then what is theta m? This theta m is nothing but it is mechanical angle of the shaft in radian with respect to the fixed reference. Please remember, this is important. This is the angle with respect to fixed reference. Ta is the accelerating torque in Newton meter, and already we discussed Ta will be equal to what? Tm minus Te. Now the rotor speed will be changed by a insignificant magnitude. The rotor angle also changes. So to remain the speed at a constant magnitude, the equation 1 can be converted into more suitable form. Now what we will do? We will multiply this equation number 1 by omega Sm. Now the question is, why we are multiplying it by omega Sm? As we want to think about a power, so we know that power will be equal to torque into speed, or will be equal to what? Torque into speed. So I am going to multiply this equation number 1 to the both side by speed. Speed is omega Sm. So what we will get? J omega Sm into 10 raised to minus 6 d square theta m upon dt square equal to Pm minus Pe. Now why we have multiplied by 10 raised to minus 6? Because always the unit of the power is in megawatt. Now, how you will get Pm minus Pe? Because you know that torque is what, or you can say accelerating power will be equal to what? Torque Ta into speed omega Sm. So once we multiply the equation by omega Sm, then torque into omega Sm will be accelerating power, and this accelerating power will be equal to what? Pm minus Pe, where Pm is the mechanical input power in megawatt, Pe is the electrical output power in megawatt. Now here the copper losses are assumed to be negligible. Now what we will do, as we know that relationship, what is the relationship between electrical angle and mechanical angle? We know theta E will be equal to P by 2 into theta M. So from that we can write theta M will be equal to what? 2 by P into theta E. Now what I will do, instead of this omega Sm, whatever this omega Sm is there, I will write this equation omega Sm in terms of omega S. Now already we discussed what is the meaning of omega Sm and omega S in dynamics of synchronous machine. This is a synchronous speed, but it is a mechanical, and this will be electrical. Synchronous speed, but it will be in electrical. So how we can write omega S will be equal to what? Omega S, or I will write it as omega Sm will be equal to 2 by P into omega S. So in place of this omega Sm, what I can write? 2 by P into omega S. And the next is nothing but, here the term is d square theta m upon dt square. So here please see this expression. Suppose if I differentiate this equation twice, then what I will get? D square theta m upon dt square will be equal to what? D square theta E upon dt square. Is it? And but obvious, the portion 2 by P will be there. The portion 2 by P will be there. So therefore, what I will do, this J as it is. Now omega Sm is nothing but 2 by P into omega S. So that's why 1 2 by P is for this into omega S into 10 raised to minus 6 is as it is. And but obvious, here we should have this 2 by P square also multiply, 2 by P also multiply by this. So the other term of 2 by P comes from this. It comes from this, basically from this theta m equal to 2 by P into theta E. Just we differentiated here twice. There is no question of differentiation of these terms, so it will be constant 2 by P. So this 2 by P into this 2 by P becomes 2 by P square. Omega S, this term omega S we have written into 10 raised to minus 6 as it is, and instead of theta m, now we are writing theta E. So d square theta E upon dt square will be equal to Pm minus Pe. Now what is this theta E? This theta E is nothing but, it is rotor angle in electrical radian. It is in electrical radian. But already we studied this relationship, that is moment of inertia. We have studied this, or angular momentum you can say. What is the formula in dynamics of synchronous machine? Already we covered. M equal to J 2 by P square omega S into 10 raised to minus 6. Unit is megajoule second per electrical rad. So what I will do, for the place of J 2 by P square omega S into 10 raised to minus 6, I will write it as M. So I will get this equation, M d square theta E upon dt square will be equal to what? It will be equal to Pm minus P. Now it is very convenient to measure the angular position of the rotor with respect to synchronously rotating frame. Now what is the meaning of this? Let us say I will draw here a diagram. This is nothing but your, it rotates with a synchronous speed omega S. Then this is nothing but your speed is nothing but omega here. Now I will draw this dotted line. Now what this dotted line indicates? This dotted line indicates it is stationary reference frame. This will be a stationary reference frame, and angle between these two is nothing but theta E. Angle between these two is nothing but theta E. Now what is this value? This value will be what? It is omega S into T. Omega S into T, and angle between these two is nothing but a delta. So what this line indicates? This line is nothing but synchronously rotating reference frame. This is what? Synchronously rotating reference frame. And what this line indicates? This indicates actual rotor axis rotating with the actual rotor speed omega. What is this? Actual rotor axis rotating with the actual rotor speed omega. So from this diagram, can I write a mathematical expression of angle? What is your theta e? This is your total angle theta e, which will be equal to what? Delta plus this is what? This is your omega s into t. So this will be omega s into t. So here we have written this expression, where delta is nothing but what? It is rotor angular displacement from synchronously rotating frame, that is rotor or a power angle. Delta, let's say this is the angle between this axis is called as what? This is your synchronously rotating reference frame, and this axis is called as actual rotor axis rotating with actual rotor speed. So this is the angle between these two, which is called as a delta. Now what I will do, I will differentiate this equation number 6 twice. Now why we are differentiating it twice? Because if you see in equation number 5, we have a double derivative, that is d square theta e upon dt square. So if I differentiate this once, what we will get? D theta e upon dt will be equal to what? Omega s, okay, plus d delta upon dt. And if I again differentiate this with respect to time, then it will be what? D square theta e upon dt square. This omega is the constant, so derivative of this is 0 with respect to t, and here you will get d square delta upon dt square. Means in place of d square theta e upon dt square, here in equation number 5 we can put d square delta upon dt square. So here we can put this, and therefore if we put this in equation number 5, then what we will get? We will get equation m d square delta e upon dt square will be equal to Pm minus Pe, that is in a megawatt. This is your equation number 8. But what is m? We know that m equal to Gh upon pi f. Already we have studied this. It is in megajoule second per electrical rad. So if I put the value of m here in the above equation, we will get Gh upon pi f d square delta e upon dt square equal to Pm minus Pe in megawatt. And how we can represent this in a per unit? Just what you have to do? You have to divide by g to the equation number 9. So what you will get? H upon pi f d square delta e upon dt square equal to Pm minus Pe. It is in per unit. So here equation number 8, this is very important. Then your equation number 9 and this equation number 10, it describes a swing equation. And what it gives you, the information, it describes the rotor dynamics for a synchronous machine. Now in above second order differential equation, the damping term is ignored because the machine under consideration is assumed to be lossless. So that's why during the starting of this video I told you what is a swing equation. Swing equation is the second order differential equation that gives a relationship between angular momentum, then load angle delta, and accelerating power, which is equal to Pm minus Pe. So this is what is the derivation for a swing equation. If you have any doubt, please feel free to ask. Subscribe my channel. Thank you.